Hello everyone, welcome back. If this is the first time, then welcome to this channel. We have today lead code 791 custom sort string. It's been prioritized by Facebook, Google, and I think Apple, probably among other companies, who knows. The question reads that you are given two strings, order and s. All the characters of order are unique and are sorted in some custom string order previously. Permutate the characters of S so that they match the order was sorted. More specifically, if a character X occurs before a character Y in order, then X should occur before Y in the permuted string. Return any permutation of S that satisfy this property. Okay, so there are probably many ways that you guys could solve this question, right? You could probably build like a priority queue, and feed it elements, of a certain type. Like maybe you go through order and then you create elements, maybe a class where you have like a C and its corresponding position in order, and then you go through the S and then you add those you know elements to the priority queue. The priority queue is sorted for you, but that's an n log n solution, right? You could probably use a priority queue. How do we make it better? um I think the best way to make it better is to go through it. Unfortunately, you have to go through it three times, and I have the solution right up here, right, where initially we go through the string s, right, and then we build an accurate map of the elements in s. Notice that the elements in order, right, they are unique. However, those in s, they can be repeated, right, and it can be in different like configurations. So basically, I build a map with s, right, all the elements in s, and we know that everything in order is already ordered, right? So we start from the beginning of order, right? And we check if the element is in S already, right? If it is in S, it's previously in S, then we add it, right? We add it for a number of times that it occurs in S, and then we continue and we continue. So once we are done with order, right, then we'll go through the map. uh, it- we'll go through the map, and then the remaining characters, like for example, D, right, who still has a count in our map, right? Then we just add it to the end of the string. So that's one way to add it. You can have like these starting, obviously, but they are more interested in the CBA, for example, all those the stuff that okay in the order. But what I want to do is go through order first, and then go through the remaining stuff in string, in the map basically. So that's a simple solution. Like let's just hop into the solution in Java, right? So to make the map, right, we have it's been told that the length of order can be at most six characters, right? And then we've also been told that it's lowercase letters. So it's fine for us to build a map of what 26 letters, right? So map new int, and then you have 26 letters, right? And then we are going to go through each character in what in S. So S dot to carry. So, oh come on. So we go through each of them, and I need to basically C minus A, right? We have to shift for the indices, right? So that's why we have the minus A, right? So whenever we meet an element in S, right, we increase what um its corresponding value in the map, right? So that's done. You have a map to get a good understanding of which elements and how they occur in C, sorry, in S, and now we're going to go through the other map to have car C in what order to carry, right? Now, basically, whatever we have in C, we just want to add it. And I know I should probably have built the string builder here, right? But basically, once we go through every element in order, right, we'll just add them to our string builder. We add each and every one of them to our string builder. And once we are done adding, right, then we go through with the ones which are the remaining elements. So while we're going through the string builder, right, if we meet a count of let's say A, and A has a count at this index of 3, right? as many times as we have three, right? We reduce a three times, right? And then we add that as many times to our string builder, right? Now we call our string builder, call it SB, new string builder, SB. And so we add into the string builder. Right, we'll add C to our string builder, and then we will reduce, C by its appropriate term. So to do that, we want to have a while loop, right? So we say while map C minus A, so right, C minus A that at that index. Now, while that is greater than zero, right? Then we can keep adding to our SB. So SB dot append C, right, and then map C minus A, right, minus, right, looks clean. It does that for every element in the order. Now, what we want to do is just now go through our map, right, for the elements who are still left. Or we can even go through S, right, and then find which elements are left, right? So for car, C in not S dot two car array, right? If you've not used up every one of them, right? So that if the map C minus A, come on, if this is still greater than zero, right? While it is greater than zero, just add to our SB, right? Basically the same thing as above SB to append, and then I think probably can use this. So those who are still left after we use those in order, right? Like the D here, who doesn't occur in order, um, then we add it to our SB, and then at the end we want to return what our SB dot to string, right? Convert our string data to string, and then return that. Um, Passes the first two test cases, and it's probably going to pass the last one too. So yeah, pass of the case is 100% O of n solution, right? O of n operation here, O of n operation here, O of n operation here. We have three O of n operation, right? So it's O of listen, 3n, but still three n is O of n. So thank you guys for joining me on this video. Hope you got a lot from it. I'll see you guys on the next one.